Hello everyone, and welcome to the continuation of our modeling, analysis and design of a two-span pre-stressed beam deck, which is basically part of a bridge design video series, which I'll be linking on the top right. Of course, once again, the clarification that this is a quick side series because we need to cover the basics of Autodesk Structural Bridge Design in hopes that we can use it to design a highway bridge, because designing a highway bridge is much more complicated than this simplified bridge. But the simplified bridge is necessary to at least understand how the software works. And in today's video, we are going to define our diaphragm and some nominal beams or dummy beams that we're putting on the two sides. And with that being said, let's dive into the video. So sit back, relax, and enjoy the show. Okay, now what is basically a diaphragm? A diaphragm is an element that is being put on the support line to kind of help the support the bridge. Alright, so let's start defining our diaphragm and applying the diaphragm and the nominal beam to the model. A very, very important thing I need to mention is that I have updated my software to Autodesk Structural Bridge Design 2025. So maybe the GUI has changed, and I really highly urge you to modify or update your software to Autodesk Structural Bridge Design 2025. It just came out recently, and I think it's best to always keep the recent softwares to be used. Now, a diaphragm is not a beam, it's just basically a rectangular element. So I'm not going to use pre-stressed beam and whatnot, because if you click on design beams, you can define your beams, and this was explained before in a previous video, which I'll be linking on the top right. But this time, no. This time we are going to define our own sections. So I'll define something called design sections. I right-click here, add me a section. Now, I don't have an existing design section, but I have a parametric section. I can basically add me a parametric shape. Parametric shape means a shape that I define by giving the values of the parameters of that shape. It's actually really easy. If you click on that, you can see that the shape can be rectangle, circle, and so on. I'll select a rectangle, and for a rectangle, I need the width and depth. Now, the width of the diaphragm is going to be 600 millimeters, and the depth of the diaphragm is going to be 1470 millimeters, 1470 millimeters. I know what you're thinking. Why would you assume a width such and such and a depth such and such? The width 600 millimeter is an assumption that I assume freely. It's up to me. I can assume any width I want. The width of the diaphragm could be, not should be, it is usually the width of the support. This is only a suggestion. Feel free, of course, to not follow it if you want, or you can follow it if you want. That's on you. Tell me in the comment section if you think that the width should be different. For the depth, why 1470 exactly? Because this is the height of the bridge, including the slab. Now, what is the hook point? I never talked about this before. Maybe I did, but just quickly. The hook point is the point of the origin of the section, because a section has a centroid and also has an origin. And this will become important when you draw your beam or this element into the structure itself. So we need to modify this hook point. We need to modify this origin. Now there are multiple origins. If you toggle 1, 2, 3, 4, you can see the points moving around, like it's just the four corners. And I can even add me a -1. Now I'm going to go to the hook point -1 because it gives me the center here. And I will basically shift it in the Z, 0, basically, and the Y to be at 0. What does it mean? It means that the coordinates here are at 0, 0 in the coordinate plane, because you see if you move here, like look, if you put 300 here, look what happens. It just got shifted because that is my 0, 0 now, and the origin here is at 300 in the Y, as it's called here, and 0 in Z. Now I want this point to be in the center of the coordinate system, so I have to put 0, 0. So now it's in the center of the coordinate system. Now this defines my diaphragm element, and I should call it diaphragm, by the way. But there is one thing that remains, which is the property. At the moment it's void, meaning there is no material. No, I want it to be C3240. Of course, you could choose a different material if you want. I'm gonna stick with this. And with that being said, I click OK. And right-click here because I want to rename it, and basically say here, this is diaphragm. Fantastic. So now I have my diaphragm section. Remember, the hook point was here. This will become relevant very soon. The second thing I need to do is I need to add a small nominal beam for the edge of the slab. I right-click here, add, and select new section, parametric. With that, I want to add my own thing. Now, this is a dummy beam, so it must not be large because I don't want its stiffness to affect anything in my calculation. You could put 1 millimeter by 1 millimeter or 10 millimeter by 10 millimeter. This is a ridiculously small beam. And in order for you to see the hook point is important, I will show you what the difference is between a hook point and the origin later. So for now, the hook point, let me see, I'll just zoom in, it's pretty hard to see. Now this thing is going to be on the top at the slab, because I told you this is like gonna be in the slab. So this is gonna be at height 1470, or basically I think it's 1370 because the slab is 200 millimeters. Wait, let me think about this. I need to think a little bit. Structure definition, let me think. So, okay, this ground is my 0. So if I want to put a dummy beam here, then I would need the center of the beam to be how much from the ground? 1470 is the total height minus the thickness, or half the thickness, so total height minus half the thickness of the slab. The thickness of the slab was 200 millimeters, so half of it is 100, meaning 1470 all the way up minus half of this, it's going to be 1370, yes. So I will go to my design section, right-click again, add new section, parametric, and here I will add me a 10 by 10 millimeter, and I'm going to reference 0, meaning I'm going to reference the centroid of it, because I want to push the centroid now, and I'm going to push the centroid nothing in Y, so it's dead in the center, but in the height, I'm going to have it as 1370. So basically, it's in the center of the slab. Yeah, I think this should make sense. Okay, let's see. So yeah, I think it makes sense. So I just select concrete here. Once again, I'm selecting the deck slab concrete. Now that's not a choice because the nominal beam is in the deck slab, so I have only one choice of concrete. A different choice is incorrect. And yeah, okay, I think I'm done. I select OK here. And I will right-click here. And let's see, rename this to be, I don't know, dummy section, nominal section. I don't know, I'll just keep it like this. I'll save because this software has a tendency of breaking apart. Oh, look, it's warning me now. It's warning me now that I'm saving. So it tells you, hey, you're going to change the version of the software from 2024 to 2025. Okay, so now it's saved, but it was a good warning to warn me. So please notice, dear viewers, that you need Autodesk Structural Bridge Design 2025 to continue this tutorial. Now we have defined our design sections, as you can see here. Let me close this now. And we want to use them. So if I go to structure definition, or properties, sorry, I'm going to right-click here, add, and add those design sections. So if you click here, of course, it tells you, let's add a design section. I'm going to use my diaphragm, and we need to add the diaphragm, okay? So the description here is diaphragm. You can change the name, but it doesn't make any sense. And here is the section reference to. Now, I specifically moved the origin of the section to be able to help me make sense of it. So I already modified the origin for it to be in the correct position. Okay, so here is a good chance to see the difference between origin and centroid. So let's see what happens if we click on origin. Okay, so now I want to add or assign the diaphragm to some elements. So if you go to structure graphic, which is this graphic, and if you click on the assigned member and start clicking like this, oh, it's pretty hard to select. So select those things. How can I select those elements? Now, if you click here, you see just numbers. Those are the finite element numbers or the bar numbers. Yeah, there's actually a filter box here that you can use. If you click on the filter box, you can click transverse beams, meaning whatever you select now, you're going to select transverse beams. I still have to be a little bit careful on how I select those things. So I click on plan, and now I think I have I think I have them. Yeah, I think I am able to. It's easier a little bit, not that much. Okay, let me just try to select them correctly. So I have those three things. By the way, I'm using the middle mouse button as my panning button. You can use it too. And so on. You can see that this is a little bit annoying, but okay, it's not that much. Now I used origin specifically. So I click OK, and I'll save immediately. Now, if you click on the 3D structure thing, you will see that the diaphragms are, let me see, I think they are done correctly. Let me remove this, so select all. Yeah, I think they are done correctly. If you go to structure properties and select diaphragm, it's the wait, let me see, it's the origin. Oh yes, I used the origin, my bad. I should have used the origin, yes. It's actually correct. If you click on centroid, then it messes up. So let me show you again. Okay, so if you click on the structural view, so you can see that it doesn't work, because if you select the centroid as your reference line, then it draws the diaphragm having the line in the centroid. Now, I remember that we put the origin in the bottom so that it's drawn correctly. So I can easily fix this by going to structure properties, diaphragms, and asking it to draw with respect to the origin, because I basically changed the origin in such a way that it makes sense. I click OK and save again. Now, we need to add the nominal elements. If we want to add our nominal section, so I right-click here, add, and select design section, which is basically my nominal section. Now we see it automatically switches to nominal section because we have finished the diaphragm, and we need to draw this. Now I want to add my nominal beams. My nominal beams are not the transverse beams. My nominal beams are the longitudinal beams, the edgiest ones. So I click on my filter here and ask it to only select longitudinal beams. By a swipe like this, I should be able to select them. So there is the first longitudinal, and then there is the second one. Now let me see. I think I should use origin. Should I use origin? You know what? Here is origin. OK, and save. And let's double check if it worked or not. Yeah. So let's click on view. And let's take a look if it worked or not. I think it did work. Yeah, there we go. It's in the center. Yes. So everything seems to be fine. The final thing I want to do here before we start analyzing, which is going to happen in the next video, is I want to add my transversal slabs. Those are beams, but those beams carry transversal slabs. So what I'm saying is we need to add slabs on the transverse direction to this. So how do I do this? I will right-click here on the structure properties. I am in the structure properties. I'll add, and I'll select a continuous slab, because I need to add a continuous slab on the bridge. You would think, why didn't you define a slab in the beam? And this is a good question. I'll explain it later. So I will right-click here, select add, and select continuous slab. And now my thickness of the slab is going to be 200 millimeters. I think I should leave it as slab. If you want, you can call it transverse slab to be a little bit more accurate, and I'm going to assign it to members. Notice I don't need to make a design section for this because it's just a slab. And for that, I need to select some elements. Once again, it's C3240, and I want to select elements, so I better switch from longitudinal to transverse. And now something peculiar happens because there is a problem. If you select everything like this, then you will select the diaphragms, which will freak out the software and it will warn you about this. Why? Because you already defined for this a diaphragm, and for this a diaphragm, and for this a diaphragm. So if you select them all, it will tell you, hey, wait a minute, this beam element has already been assigned properties. Do you want to overwrite? And the answer to this question is no. I don't want to overwrite any one of those assigned sections, because those are my diaphragms. As a matter of fact, I will click no to all, and this will only assign the diaphragm to the elements that have not been assigned before. If I click OK, this should end my assigning. I will save and click on the 3D, once again expecting the software to crash. See? Okay, so let's click on the 3D element thing, and you will see something very strange. Now, first of all, you only see those things. Let me first of all remove and select all, so no filtering. And now you see something very strange. You see that the slab is on the ground, but the slab should be on top, right? So how do I do this? I can modify this by beam eccentricities. I can ask the slab to be shifted up to 1370 to the center where it is supposed to be. So how do I do this? Now, why do I see beam eccentricities here? Those beam eccentricities have been defined automatically. Why? Because during the definition in our structure properties, we were asking the beams to be defined relative to a certain point, for example, origin or centroid. So the software automatically calculates an eccentricity and applies it. So this has been done automatically. However, because the slab has not been defined using the section design sections, which should not be done actually because it's a slab, it was defined using the section properties slab. There is no eccentricity for it, so I have to add my own eccentricity. How do I do this? I right click on the eccentricities and add me something to it. So let me add an eccentricity here. And now it's, wait, what? I added the line beam? I think I messed up. Let me just cancel. Right click on the eccentricity, add. Oh yes, I want to add something called advanced beam sets because we are in the advanced beam sets. And I want to add me eccentricities. There are all kinds of amazing things we can talk about later, but I want to add eccentricity. Now the eccentricity here makes the slab be shifted 1370 up because I want the center of the slab, which is currently on the ground, to coincide with the center of the real slab. So I need to add a plus here. In the Z, I have 1370, and in the end, I have 1370. And now I need to select my members. And once again, I need to be very careful. I could just select everything like this, which will not work, because the diaphragm has its eccentricity. As a matter of fact, it will refuse to do so. Allow me to show. If you click on transverse and select everything in the transverse, you would think you have done it right. But in fact, you have not done it right. Because if you remove the show offsets, you can see, because show offsets kind of covers up stuff, but if you remove show offsets, you can see the problem. With my selection, I selected not only the slab, but also the diaphragms. So if I click OK now, I will get a warning. Because I already have eccentricities for the diaphragm, it's not able to add eccentricities for the slabs. Now, unfortunately, there is no easy way of just telling it, no, don't do this. So I'm kind of, to be honest, annoyed. How do I do this? It's going to be painful. Like if you click transverse beams, let me clear the selection, try again. So what happens if you click transverse beams and select like this? No members found? How is that possible? Okay, let me see. Let me just select all here. Oh wait, okay, once again, 13, I think I'm messing things up. 1370. And now maybe I can assign something. There we go, I selected them, right. Now I also selected this, which should not be the case. So I will click on my selection, remove T1, which is this guy, and remove the last T, which is T25. Oh wait, not this. This, which removes the diaphragm, and remove the central diaphragm, which I have no idea what the number for it is, but the total is 25, so half of 25 is 12, I guess. No, that's not it, because you can see this one was cancelled with 12. So I think it's 13. Yeah, there we go. Okay, let's click OK and see what happens. Oh, it accepted it. Fantastic. Let me save again, and you know what's happening now, right? It will explode on my face. Click. Wait, what? Let's see. Eccentricity. Oh, not Y. It's Z. My bad. It was Z. I got so frustrated that I totally messed up. Okay, let's click OK again. Save. And now let the software explode. It didn't. Fantastic. Yes, that's what I wanted to see. So now I have everything done, everything modeled. And in the next video, we're going to be analyzing some beams and checking out some stresses. So stay tuned for that. However, before I finish, there is a very, very important point I want to mention. I know that most of my viewer base comes from the Autodesk robot software background. And from the get-go, you would freak out immediately. Because look, there are slabs intersecting with beams. So, like, let me show you. Let me just filter something. Let me just filter and say longitudinal beams. Those are my longitudinal beams, right? And if you select on the filter and click transversal beams, those are my transversal beams. It seems that the slab got defined twice. One time in this direction and one time in that direction, or this block. And for that, I will tell you, don't worry at all. This is totally normal. The way the software works, you would think, wait a minute, I don't need, you would think now, wait a minute, I don't need to define the slab here. I don't need to define the slab here because I already defined the slab here, right? It's kind of a double definition. No, unfortunately, you have to define the slab in both longitudinal direction and transversal direction for a very simple reason. The slab in the longitudinal direction is needed because the software needs to see that this section of the beam is a composite section. So it has a slab and a prestressed beam. The slab needs to be defined in the transverse beam section because you need to be able to analyze and design it as a slab. You would think, but why do you need to define it twice? Unfortunately, that's how the software works. The software, if you would think, if I define the slab transversely like this, then the software definitely must see the slab and must understand that the beam is composite. No, it doesn't understand it, unfortunately. That's why you have to do a double definition. A second thing that might freak you out is there are some gaps here, and that's totally fine, no problem. This is just a numerical or a modeling error, which the factors of safety cover. Thank God for factors of safety. So yeah, this was a quick rundown of what those problems in the slab are. And with that being said, I want to thank you very much for watching. And before I finish, I want to give a composite section size shout out to my dear channel members in the contributor level and the helper level whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as their support of the channel is priceless to me and enables me to provide you with videos hopefully on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and you found it beneficial. If you have enjoyed the video, then please consider liking, sharing, subscribing, commenting, and so on, especially subscribing because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.